In this video, we are going to be looking at division of a line into a given ratio, say u is to v. So to look into this, first of all, let's consider a Cartesian coordinate, a Cartesian plane. Let's consider a Cartesian plane. This is the y-axis and this is the x-axis, and let's consider a line AB. Let's consider a line AB, line A at point x1, y1, and we have point B here, which is x2, y2. So this can be traced down to the s coordinate. This can be traced down here. It could also be traced this way. Could be traced this way, exactly. So now consider also a point here which divides this line into the given ratio. Let's say the point 0 divides this line to a given ratio, say u here and v here, exactly. And then you can also trace this down here. You can trace this down to the x and to the y respectively. So at this point we are going to have point x minus x1. At this point you have point x2 minus x. Also here we are going to have point y2 minus y, and here we have points y minus y1 respectively. So that is what we have on this Cartesian plane. So we are going to be proving now this formula. We are going to prove with respect to the x-axis and with respect to the y-axis, respect to x and with respect to y. What is going to be the formula when we are to find the division of a line, the given ratio with respect to x and with respect to y respectively. So from here now, looking at it in respect to x, we are going to divide. We are going to divide this with this. So we are going to have it to be x minus x1 divided by x2 minus x, which will be equal to u over v. You know, this, of course, x minus x1 stands for u, and x2 minus x stands for v. If you can check, you see that. So that means this divided by this means u divided by v. So this is what we have. So from here now we are going to cross multiply. We are going to cross multiply, and if we cross multiply, we are going to have v into x minus x1 to be equal to u into x2 minus x. So let's solve this further. If we open the bracket here, we have vx minus vx1 to be equal to ux2 minus ux. So what we are going to do here is we are going to factorize x outside. That means we are going to move this to this side, and we're going to move this to this side. So if we do that, we're going to have vx plus ux now to be equal to ux2 plus vx1. So solving that further now, let's try to wrap it up here. We're going to have x outside, and you are going to have u plus v to be equal to ux2 plus vx1, and that means x is going to be equal to ux2 plus vx1 all divided by u plus v, and this is the formula with respect to x. With respect to x. So now let's also do with respect to y. We have found it in respect to x. What of y? With respect to y now, similarly to here, we are going to have it to be y minus y1 divided by y2 minus y to be equal to, of course, u divided by v, because this it goes to u, and this goes to v. So this is what we have. So in a similar way, we are going to multiply both sides, and if we multiply both sides, we are going to have v to be into y minus y1 equal to u into y2 minus y. So let's open a bracket also here. If we open the bracket, we are going to have vy minus vy1 to be equal to uy2 minus uy. So similarly, bringing this to this side and bringing this to this side, now we're going to have this to be vy plus uy equal to uy2 plus vy1. So factorizing y outside, we're going to have u plus v here to be equal to uy2 plus vy1. So that means y is going to be equal to uy2 plus vy1 divided by u plus v. Also, this is the formula with respect to y. Is a formula with respect to y. So these two formulas, let's call this formula 1 and formula 2. These two formulas are used when we are talking about division of a line into a given ratio. So we are going to henceforth be solving the examples to explain this further.